let's go ahead and start talking about Alzheimer's disease and its connection to diabetes, because I think in 2016 or 2017, people started to recognize some of the connections between diabetes and Alzheimer's disease. And it wasn't until about, I want to say 2 or 3 years ago, that the term type 3 diabetes started to be thrown around without as much hesitation as it was before in the professional ranks, the research ranks, the medical ranks. So when it comes to Alzheimer's disease, it's understanding that one of the main issues in Alzheimer's is that the brain is not able to metabolize glucose quite as easily. They've targeted plaque buildup in the nerve cells and the neurons within the brain, preventing it from properly utilizing energy and, functioning properly. And this was, 6 years ago now, but there were a couple different hypotheses that came out of this seeming connection between glucose metabolism and Alzheimer's. So one of the things had to do with high blood pressure. High blood pressure, if you don't already know, has a strong correlation with strokes and other altered brain function. Diabetes, one of the secondary symptoms of untreated diabetes is high blood pressure because of the elevated blood glucose levels stiffening and I guess stiffening is the right word, stiffening circulating blood properly. So that was one hypothesis. The other came from the opposite direction. So a lot of times when people think of diabetes, they think of high blood sugars. The other possibility being thrown around at this time was the fact that hypoglycemia, and as being a causative agent, because if you're a diabetic, you have more control over what your blood sugar is doing. You are a lot more likely to experience hypoglycemic episodes as well as you become familiar with your medications. And they were hypothesizing that in a hypoglycemic state, these brain cells, these nerve cells, neurons were being starved, if you will, of glucose. And this was causing them to exhibit this kind of altered metabolism. And then people started to come around to the idea of insulin resistance. Again, the methods weren't clear, but insulin resistance having some sort of agency over cell metabolism in the brain itself. It was well documented, well recorded in other parts of the body. It had yet to manifest in the brain. So with insulin resistance, and we have covered this in previous episodes of the podcast, talking about the development of the disease, of diabetes, of insulin resistance, and some of the behind the scenes effects that precede the development of diabetes, but also occur downstream after the disease has developed as well. So you really have to wonder aloud, with insulin resistance that diabetics are experiencing, is it because there's not enough insulin being produced and the beta cells are dying? Is it too much insulin because it's resistant? Because our bodies are resistant, are our beta cells creating too much to overcompensate, right? And in both of those scenarios, not enough, too much, what are the downstream and upstream effects of having so much insulin around? Even further upstream, okay, maybe what's the inflammation that is causing this insulin resistance, and what are the effects, the simultaneous effects of that inflammation, as well as the abundance or lack of insulin, right? So we'll talk a little bit more about protein glycation and how cells' receptors for insulin can be modified in states of inflammation and insulin resistance. And then going along that line of inflammation, chronic inflammation being the root cause of diabetes, where is that inflammation coming from? One of my favorite lines that kind of like loops in my head is that when I hear other people or other doctors talk about inflammation as a diagnosis is fairly worthless. Like, unless you can pinpoint the where and the why, right? So you go with some issue that you're experiencing, and the doctor says, well, it's, some type of inflammation. We'll give you an anti-inflammatory and see what happens. That is the surest way for a doctor to technically be correct and have no idea what's going on, right? Like, why? Where is this inflammation coming from? And then on top of that, with this abundance of insulin or lack thereof, is there something else working alongside insulin that, that's kind of triangulating or working alongside, exacerbating the issues that insulin resistance brings about? You see this graph on the right-hand side. I have a more precise, this is kind of just a doodle I did trying to visualize it for myself. We'll do something more in depth on this later on in the podcast. So if you have not heard me talk about iron overload and the development of diabetes, I'll give you the quick synopsis. So insulin resistance is born, and this is all my opinion. This is not medical advice, all for educational purposes only. Insulin resistance is born of metabolic dysfunction leading to iron overload. This iron overload and ensuing metabolic dysfunction occurs as a result of systemic mineral imbalances, nutrient deficiencies, and pro-inflammatory additives in our food and lifestyles. The resulting inflammation resulting from iron overload causes structural and functional deficits in the beta cells themselves, as well as the cell's receptors for insulin, as we'll talk about later on. And this is not unique to beta cells. There are other cells affected. I talk about this in earlier episodes, going over iron overload and the effects on the body, the effects on the pancreas, the ties between inflammation and iron overload. So plenty of more resources going into that connection in earlier episodes. And I wrote a book on it, right? So this is just a quick plug here. So I dive into iron overload and its connections to a number of metabolic dysfunctions. I'm partial to diabetes because I have type 1 diabetes, but Alzheimer's, heart disease, arthritis, any number of autoimmune conditions, PCOS, Hashimoto's, Crohn's, IBS, all of it. All of them have ties to a very little known condition called hemochromatosis or iron overload, whether the primary or the secondary version of them. I talk about all of that in that book. That'll be linked in the description.